Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NI EVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic, Chapter 3, Reading Done, Part 2. Our today's lecture number 16 and SW number 14. My dear students, let's start our class. Chapter 3, Force. Today we will prove that F equals to ma. From Newton's second law, we will prove that F equals to ma. At first, Newton's second law. The rate of change of momentum of a body is proportional to the applied force acting on it, and the change of momentum also takes place in the direction in which the force acts. If a body is moving with an initial velocity u and the velocity is changed by increasing or decreasing from u to v after a time t, then the change of momentum will be mb minus mu. My dear students, now I will prove this law. Okay, the change of momentum, that means we know momentum means mass into velocity. Okay, momentum means mass into velocity. So mass m into velocity, if final velocity b, then it will be mv, and if we write the initial velocity, then it will be mu. So the change of momentum means mb minus mu, and the rate of change of momentum is mb minus mu divided by t, and here m is common, that means v minus u divided by t, and we know this v minus u divided by t means a, so we can write ma. Okay, a equals to v minus u divided by t. We know a equals to v minus u divided by t, and since we consider that there is no change of mass, so we can write like this. Okay, now and from Newton's second law, we know the rate of change of momentum of a body is proportional to the applied force. That means this is proportional to the applied force, so we can write F proportional ma. Okay, F proportional ma. So and we don't want to express this law in proportionality form, so we can write F equals to k ma, and this k is proportionality constant, my dear students. But we don't want to express the law in proportional form, rather we want to write it as an equation, and in this case we using a proportionality constant k, and we can write F equal to k ma. And if the force is F and the proportionality constant is considered as 1, if k, we consider k is 1, then we can write F equals to ma. So this law is proved. Okay, now according to this law, we will solve some problem. Problem number 1: a force of 100 Newton is applied on a stationary body of mass 5 kg for 10 seconds. Number A, what will be the acceleration due to this force? Number B, what is the velocity after 10 seconds? Number C, what is the velocity after 20 seconds? Number D, what is the distance traveled in 20 seconds? My dear students, number A, what will be the acceleration due to this force? Here given, my dear students, here given force F equals to 100 Newton, then we have to find out the acceleration. Okay, and mass, here given mass is 5 kg, so we have to find out the acceleration A. So we know F equals to ma. From here we can easily find out what is the acceleration. F is 100 Newton and m means 5 kg, that means 20 meter per second square. Acceleration is 20 meter per second square. Now number B, what is the velocity after 20 seconds? My dear students, here given force 100 Newton, mass 5 kg, acceleration 20 meter per second square, and time is 10 seconds, and initial velocity, this is the stationary body, that's why initial velocity u equals to 0. So for number B, we have to find out the what is the velocity after 10 seconds. That means we know v equals to u plus at. Okay, so u is 0, here a is 20, and t is 10 seconds. So t is 10 second. My dear students, 20 into 10 means 200 meter per second. The velocity will be 200 meter per second. Now come to number C. What is the velocity after 20 seconds? My dear students, force is applied up to 10 seconds. In the question, stream said force is applied up to 10 seconds, and after since force is applied no more, therefore after reaching the velocity of 200 meter per second, its velocity will be unchanged, and that is velocity after 20 seconds is 200 meter per second. Okay, now come to number D. What is the distance traveled in 20 seconds? Distance traveled in 20 seconds has been determined in 2 steps. Okay, distance traveled in the first 10 seconds, then we will find out the distance traveled in the second 10 seconds. At first, distance traveled in the first 10 seconds, that we know s1 equals to ut plus half at square. Here initial velocity u is 0, and time is for first 10 seconds, so time t is 10 seconds, and plus half into a. Acceleration here given 20 meter per second square into time whole square. So that means distance traveled in first 10 seconds is 1000 meter, and distance traveled in the second 10 seconds s2 equals to vt, and we get v means 200 into 10 second 10 seconds, or time t equals to 10 seconds. So distance is 2000 meter, and the total distance we know s equals to s1 plus s2. So this total for first 10 seconds total distance is 1000 plus 2000, that means 3000 meter, and we want to this meter into convert into kilometer. This we want to convert this meter into kilometer, that's why we have to divide with 1000. Okay, that means 3 kilometer. Okay, so the distance traveled in 20 seconds is 3 kilometer. My dear students, now come to problem number 2. A force of 20 Newton is applied on a stationary object for 10 seconds, and the object covered a distance of 100 meter. What is the mass of the object? My dear students, here given force F is 20 Newton, time t is 10 seconds, and distance is 100 meter, mass m is what? Initial velocity u equals to 0, because this is a stationary object, so that's why initial velocity u is 0. So we know s equals to ut plus half at square. We have to find out the mass, and at first we have to find out the acceleration. So s equals to, we know s equals to ut plus half a t square, and we know s equals to u is 0, that's why this part will be 0, and half a t square, and we have to find out the a. So a t square equals to 2s, so a equals to 2s divided by t square. Here we have to put this value. S means 100 and t means 10 whole square, that means we will find 2 meter per second square. So acceleration is 2 meter per second square, and then we have to find out the mass. What is the mass? And again we know F equals to ma. We have to apply this formula. Okay, so m equals to F divided by a. F is here 20 Newton. Okay, and a is 2. So 10. What will be? It will be 10. The unit of mass is kg. So it will be kg. Okay, this is the answer. My dear students, now come to number 3. Problem number 3. Problem number 3. 2000 Newton force acts on a body with 20 kg mass for 0.1 second. What is the change of momentum? My dear students, here given force 20,000 Newton time t is 0.1 second. We have to find out the change of momentum, and we know from Newton's second law, we know force F equals to the rate of change of momentum, that means mb minus mu divided by t. Okay, we will apply this formula and we have to find out this one. Okay, mb minus mu equals to ft. That means here given f 2000 into t means 0.1. So 2000 into 0.1, that means 200 kg meter per second. Okay, this is the change of momentum. Okay, my dear students, now come to problem number 4. How much force on a body with a mass of 50 kg will cause 4 meter per second square acceleration? And here given the mass of this body is 50 kg and acceleration is 4 meter per second square. That means you have to find out what is the acceleration, that my dear students, and I think all of you have understood which formula will be appropriate for this problem. Okay, now problem number 5. A boy hit a box with a mass of 20 kg with a force of 50 Newton. How much is the acceleration of the box? My dear students, this is the similar problem. Now come to problem number 6. A force of 10 Newton acts on a stationary body of mass 5 kg for 2 seconds. After 5 seconds, another force of 20 Newton acts on it for 3 seconds. What is the distance travelled by the object? My dear students, now a force of 10 Newton acts on a stationary body of mass 5 kg for 2 seconds. Here given the mass of this, the force is applied force is 10 Newton. And a stationary body, that's why initial velocity is 0, u is 0, mass of the body is 5 kg and time is 2 seconds. That means here will be you have to find out the acceleration. Okay, so what will be the formula? The F equals to ma. Use this formula, F equals to ma, and then you have to find out the acceleration, F divided by m. Then you have to find out the distance travel. Okay, distance S1 equals to ut plus half a t square. This for this use this formula, then you have to find out the distance, and then you have to find out the velocity of this object. Okay, that means v1 equals to u plus a t1. Use this formula, then you have to find out the velocity. Okay, then if after 5 seconds another force applied. Okay, then after 5 seconds you have to again you have to find out the distance. What will be the distance? This distance will be s2, then s2 v1 t. Okay, it will be t2 after 5 seconds. For 5 seconds it will be the body will be in uniform velocity. That's why you have to find out this distance, s2 equals to v1 into t2. Then 20 Newton acts on it for 3 seconds. Then again you have to find out the acceleration, that means a2 equals to f2 divided by m. Then you have to find out, use the acceleration by use this formula, and then again you have to find out the distance is 3. Okay, distance is 3, that means u t plus half t square, and this ut will be this velocity. Okay, that means v1 s3 equal to v1 t3 plus half a t3 square, a2 t3 square. That means this time for 3 seconds. Okay, this time t3, it will be t3. So use this formula, you have to find out the distance, then you have to find out what is the distance travelled by the object, the total distance you have to find out, s1 plus s2 plus s3. Okay, this is the final distance. My dear students, I hope you have understood our today's topic properly, and do this SW. Your SW number is 14 and SW topic is this math 4, 5 and 6. This is your SW topic and submit it on Saturday. My dear students, I hope you have understood your today's topic. Keep practicing at home. See you again in the next class. Allah Hafiz.